Okay, so the squeeze theorem or sandwich theorem says that if f of x is at most g of x, which is at most h of x, such that the limit as x approaches a of f of x, I beg your pardon, of f of x equals the limit as x approaches a of h of x equals any constant L, then the limit as x approaches a of f of x equals the same L. Basically, it says that in simple terms, if a is at most b, at most c, and a is the same as c, which is 2, then we can conclude that b is 2, because that is the only way this statement can be true. So, in the sandwich theorem or the squeeze theorem, to evaluate the limit in the middle, we need to evaluate the limit on the left-hand side and the limit on the right-hand side. If they are equal at a particular value, then we can conclude that the expression in the middle is equal to that value. Now, basically that's what it means, because here we could see that if f is in the middle at a point A, if the upper part, which is h, is equal to the lower part, which is g, then at this point, the limit as x approaches a of f of x will be equal to the value of y. Let's call it L at this point. Let's see some simple example. They said find the limit as x approaches -1 f of x if for all x this statement is true. Now, if we take the first one, we need to evaluate the limit on the left and the limit on the right at x is equal to -1. If the left-hand side and the right-hand side are equal, then we can conclude that the middle is equal to both. So basically, on the left-hand side, we find the limit as x approaches -1 of -4x plus 6. And this is basically 10. On the right-hand side, the same procedure. On the right-hand side, the same procedure. If we evaluate the limit as x approaches -1 of x squared minus 2x plus 7. Remember, as x approaches -1, x squared approaches -1 squared, which is 1, and -2x approaches -2 times 1, which is +2. So this is 10. So we can conclude that this expression on the left-hand side is 10. We can conclude that from this statement here, the limit as x approaches -1 of the left-hand side for x plus 6, which is at most the limit as x approaches -1 f of x, we take the limit throughout the expression, which is the limit as x approaches -1, x squared minus 2x plus 7 raised to 10 at most limit as x approaches -1 f of x, which is at most limit, as x approaches -1 f of x, and this is 10. So since the lower part and the upper part are equal, we can conclude that the limit as x approaches -1 f of x is 10. Now, in some situation where the left-hand side and the right-hand side are not equal, then the limit does not exist. Make sense? Let's see one more example. Number 36, it says, find the limit as x approaches 0 f of x for all this expression. Now, if we take a look at this, if we take the limit, this is 4 cosine 2x, which is at most f of x, which is at most 3x squared plus 4. We want the limit as x approaches 0. Now, if we take the limit on throughout, the limit as x approaches 0 of 4 cosine 2x will be at most the limit as x approaches 0 of f of x will be at most the limit as x approaches 0, 3x squared plus 4x. As x approaches 0, cosine 2x approaches 1 because cosine 0 is 1. So the left-hand side becomes 4. This is the limit as x approaches 0, f of x. And the right-hand side, as x, I beg your pardon, this is 4, not 4x. It's 4. As x approaches 0, the right-hand side becomes 4. So we can conclude that the limit as x approaches 0 of f of x is 4. Remember, if this number on the left was different from the number on the right, then the limit does not exist. So this limit is 4.